Welcome. My name is Angelo Strano. I am the team leader working at the European Commission, Director General for Innovation and Research, and I support, together with my team, EU-funded research results and their go-to-market journey and spreading and disseminating the knowledge to make an impact. Now, today we have three distinguished guests that will talk us through about the success story around the company PARASTRUCT. We have Georg Breitenberger, CEO and co-founder of PARASTRUCT, and Freia Ruegenberg, co-founder and chief scientific officer at PARASTRUCT. PARASTRUCT is a company that has been established in 2023, based in Austria, operating also in Germany, that is committed to decarbonizing construction industries with a technology that reactivates mineral binders from waste and creates a green alternative for a more sustainable construction material, such as cement. We also have today Anna-Liisa LAARITS, who is a project manager at the European Institute for Innovation and Technology, and she is particularly responsible for the knowledge and innovation community on a new European Bauhaus. So, without further ado, let's hear more from our guests. And please, I'd like to hear from Freia and Georg, what factors have enabled PARASTRUCT to accelerate their go-to-market journey? Freia, maybe you would like to start on this?
Yes, sure. I think, first of all, the AWS Seed Grant, which is a grant from the Austrian government's investment bank, was a great help because it enabled us in this stage to go to the trade fairs. And going to trade fairs really gave us the opportunity to have a stand there to present our products physically and also to provide our customers from construction and building material industries with substantial proofs or something they could really touch. Because, as you may know, the construction industry is a quite traditional business. So many things are based on personal contact, and it is really important to be there in person and to gain trust with the customers early on. So for us, it was also an opportunity to get first-hand-on impressions of the challenges and of the customer needs, so that we also could adapt our offerings. So it took us also a few feedback loops until we found the right go-to-market strategy. And with this final go-to-market strategy, we were then also able to generate traction in this rather traditional and conservative market. So, for example, we realized that we needed to start with low threshold products that are as close as possible to conventional products. So products that are just the same in processing or also similar applications to the ones that are already on the market. And at the same time, it also became clear that there is a large growing demand for more sustainable alternatives to the conventional products. And we can meet both these requirements perfectly with our first product range, which is the biomaterial range. So to sum up, the grants really gave us the opportunity to get this hands-on contact with real customers on trade fairs, which helped us a lot.
Thank you very much, Freia. Georg, would you like to add anything? No, we cannot hear you. Okay.
Our Freia has just said, in the next week we will launch our first building product. The brand name of this product is BioScreed. It's a sustainable floor structure that replaces cement screed. It consists of recyclable mineral binder and wood flour, a byproduct from the timber industry. However, it's not only wood flour that we can use as a filler, but also other biogenic waste and byproducts from the agriculture industry, such as hemp, rice husk, fast-growing grasses like jumbo grass. This also makes it easy to produce casting compounds, which we have already used to manufacture wall and facade panels like you can see in the background. And you can show also now some pictures about the facade panels. Yeah, here you can see some facade panels, 3D printed facade panels, and also what facade panels what we have produced with casting methods. As these and similar products do not require complex certification, we can enter the market quickly and easily. Customers can therefore make high quality use of their waste and buy products. With our technology and we can valorize waste streams, and we can use building components as a CO2 sink. Thank you.
Thank you very much, Georg, and thank you also for showing with these images what do we mean exactly, and we can have really a feel of what is the outcome of your activity. So now I'd like to ask you both, Georg and Freya, a question more about the support that you have been receiving from the European Union, financial support, but also opportunities and services. In particular, I would like to know more from you about your experience with working with the European Institute of Innovation and Technology, IT, in the framework of this new Bauhaus. But at the same time, also your experience with the Empowering SME and Startup Initiative, which has been funding provided to you so that you could attend a pitching event in 2024 organized by the European Business Angel Network. So tell us a bit more about that, Georg.
Yeah, so the past few years, PARASTRUCT has rapidly grown from one-man company, from an idea to market-ready products. We started by joining the Built Environment Climate Accelerator in 2022 and became also part of the EIT Climate KSC portfolio. And this partnership with the EIT Climate KIC, we have gained early visibility and validation. In 2023, our journey continued with the new European Bauhaus booster, which was an additional support and led to initial funding from the EIT manufacturing. Key turning point came when we secured the SAFE agreements with the EIT Climate KSC and the EIT manufacturing. These were not just financial boosts, they were powerful strategic. They have leveraged our business a lot. Together, these agreements de-risked our business model and propelled us to DRL7 and our first commercial pilots, what we are doing in the moment with in the steel industry and also in the aviated concrete industry. Along this way, we were honored with the EIT Circular Economy Prize, and our co-founder Freia expanded our network further through the Supernovas program and of the EIT community. Thank you.
Thank you. Congratulations for the Circular Economy Prize, really. Now, let me turn to our third guest, because we've been talking about the European Institute for Innovation and Technology. So I would like to welcome again Anna-Liisa LAARITS, who is project manager at the EIT, particularly working on this community, on the new European Bauhaus. Anna-Liisa, can you tell us more about your work in this field and what that entails? Thank you.
Absolutely. As a Polis initiative, the objective of the European Bauhaus is to deliver the Green Deal, a set of policies to make Europe greener and more resilient. However, the European Bauhaus is not just an environmental or economic initiative, but focuses on revitalizing the neighborhood with design for sustainability and inclusion. European Bauhaus has always been bottom up. To date, nearly half of the initiatives have been self-organized and privately funded. As of this year, though, we also benefit from around 120 million in annual funding from the European Commission. And this funding is then used to identify and support a range of design-led approaches that contribute to a fairer society and hopefully also more sustainable ways of living. ESG Community in European Bauhaus was one of the very first public sector funding bodies to join the initiative and to then support the systemic change that the European Bauhaus calls for. It brings together several European institutes of innovation and technology, including EIT Food, EIT Manufacturing, Climate Kick, and EIT Urban Mobility.
Thank you. Thank you very much, Anna-Liisa. I have another question for you. Why was PARASTRUCT of particular interest for the EIT, for your community? What is really that made that difference and cemented, if you want, this collaboration?
From the end of EIT Manufacturing, we are interested in circular and regenerative approaches for the built environment, including the use of such advanced manufacturing technologies and processes as 3D printing, robotics, building information modeling, and parametric design, for example. And what we really liked about PARASTRUCT was that their impact extends well beyond the construction industry to the local community and the neighborhood. And it was the founders' commitment to a green and low carbon built environment that led us to invest into the startup. One of the next steps for PARASTRUCT would be to scale the technology and to validate its feasibility for mass scale production. However, the building sector is still very much focused on the short term only and also enormously resource intensive, then this needs to be addressed beyond the building scale at a much more systemic level, engaging stakeholders across the entire construction ecosystem, including then the EIT Community and European Bauhaus.
Thank you, Anna-Liisa. I suppose, of course, that this community is open, is an open community. How can other startups benefit from it and participate in the activities? How is it possible?
I think the best way to get in contact with us and to learn more about the programs is via email at nep@eitcommunity.eu.
So now let's go back to PARASTRUCT and their journey to the market. I would like to ask something to you, Freia. What advice would you have to fellow innovators, other innovators, startups, to be really successful in commercializing the innovations, going successfully to the market, making an impact? What advice would you share, Freia?
Well, I think it's very important to start early enough to engage with the potential customers and the market situation, because in the end, the customer is the biggest and the most important long-term investor. Of course, it's also important to find a solution that is needed. So it's necessary to ask for customer feedback and also not to be disappointed if the feedback in the beginning is maybe not overly positive. So especially as a startup, we have to see it as a huge advantage that we are still able to be very flexible in the beginning. So we can do pilots and we can change the solution a little bit until the solution market fit is really given. And then, of course, when we have a solution market fit, it's important to choose the most promising direction and focusing on that. At the same time, I think it's also very important to establish a relationship with the funding bodies. So especially aspects with a high need in research can benefit enormously from public grants and investments. And I think what's important here is in the event of rejection, it's very important not to give up straight away, but to get feedback and ask for feedback and ask what you can do better and make corrections if it's possible. Because sometimes it's really the case that the money wasn't really enough in the first time you applied. And it would be really a pity that a great solution falls through just because there is a lack of persistence from the side of the startups.
Yeah, thank you very much for this. Now I'd like to wrap up with the final questions, a bit more about your technology, your solution. Explain us a bit more, how is it different from from the competitors, from what is available. So really at the core of the innovation that you have come up with, what can you tell us, Freia?
The biggest differentiation and advantage is our core technology, which is the recyclable mineral binders. So mineral binders are the agents in construction materials that are responsible for the strength properties of a construction material, and we are able to reactivate them, so to make them really recyclable. And working with these recyclable mineral binders enables us to offer a broad range of solutions that can generate a major impact in the construction industries. So first, we have, for example, the biomaterials mixtures we were already talking about. And these can replace unsustainable building materials such as cement in some applications. And they can also contribute to CO2 storage because they contain these biomaterials. But the binder technology also allows us to extract, for example, binders from other waste and side streams, such as side streams from the steel production, which can also be used instead of cement in some applications. And the most direct input, of course, comes from the recycling process for mineral binders. If we directly reactivate, for example, cement and other binders from construction waste streams. So we can really give them back the binder properties so that they can be used again and again without the need for primary raw materials. The best of this binder recycling process is that it consumes only about 50% of the energy compared to the primary production of mineral binders. And we do not have any raw material related CO2 emissions. So, as you may know, mineral binders are often made from carbonate rocks, and producing the clinker or producing the binders requires the decarbonization of these rocks. And this is the process in which most of the CO2 is produced. And we can cut these CO2 emissions completely. So also to sum it up, what differentiates us is our material variety and the efficiency of the binder recycling process.
Freia. So this brings our talk today to an end. I would like again to thank all of you for having participated, Georg, Freia, and Anna-Liisa. And we really learned a lot. Hopefully this testimony about PARASTRUCT and the journey of PARASTRUCT towards commercialization and impact has been useful, insightful, and I thank you for listening and watching, and goodbye.